Hey guys, welcome to the second section of your right triangle trigonometry notes. Remember, we have covered the functions of right triangle trigonometry. The three main functions are sine, cosine, and tangent. These are what the functions look like. Remember that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And we get these opposite adjacents from the measures of the sides of the triangles, and we label them based on our angle that we're looking at. So this is our variable angle, our theta here, and we always remember that we can always label our hypotenuse first because it's directly across the triangle from our right triangle, and next our opposite side is directly across from the angle that we're working with, and the adjacent, it's the third piece, it's the third side. It's cool. So the next thing that we're going to look at is using our Sohcahtoa, our shortcut to remembering what function that we use, and we are going to apply it to finding the missing side of a triangle. So what we're going to need to go ahead and do is you need your notes open and you need your Desmos calculator open. Remember, with your Desmos calculator, guys, our first step when we're working with right triangle trigonometry is we go to the wrench and we put it in degrees. We go to the wrench and we put it in degrees. If we do not put it in degrees, our answers are going to all be wrong. So, wrench, degrees, and click back over. And remember that this little keyboard down here will give us all of our functions that we need. So let's get back to our notes. When we are going to be solving for a missing side, these are the steps that you can follow. We're going to use the little man technique to label our opposite, our hypotenuse, and our adjacent. We mark out the side that we don't need. So if we have one side that has no information given for it other than we can label it our opposite or our adjacent, we don't need it. Mark it out. We're not worrying about it. We're going to then choose the trig function that we will need using Sohcahtoa. Remember, SOH stands for sine equals opposite over hypotenuse. Ca equals cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So each one of these has a meaning. So if we're over here and we look at this triangle right here, we can label this is our hypotenuse. This is the angle we're working with. So what's across from it? This is going to be our opposite, and this is going to be our adjacent. So when we work through these, well, this one doesn't have any information. This side, our opposite side, doesn't have any information, so we just mark it out. When we're going to be looking, if we were going to solve for this, our adjacent and our hypotenuse, what will we use to solve for our adjacent and our hypotenuse, if that's what we have to work with? If you said cosine, you would be right because we have our adjacent and our hypotenuse, and this tells us that that's what we're going to be using. So let's solve this step by step. So step number 1, use the little man technique to label your OH and A. So let's put our little man on here. It's a pink triangle, so we'll make a little blue man. So we put our man by the angle that we're working with. Well, this one only has this 18 right here marked. So this is going to be the angle that we're working with. So according to this angle, what is straight across from it? It's our opposite. So we labeled the opposite. What is the side that's straight across from our right angle? It's our hypotenuse. And what's this third side? Well, it's our adjacent, and it's by order process of elimination. So we have everything labeled. Next, mark out the side that you don't need. Well, we don't need this one because it's giving us nothing. It's not giving us a variable. It's not giving us a measure. We don't even want to look at it. So we don't need it. The leftover letters, our A and H, are going to determine which trig function that we're going to use. So if we have an A and an H, what do we use? If you say cosine, you're correct because cosine equals adjacent over hypotenuse. So we decide that we're going to be using the cosine here, and that is adjacent over hypotenuse. So what can we do now? Well, we can start plugging some stuff in. So here we're set up. We have our cosine of theta equals adjacent over hypotenuse. So let's set up our problem. Well, our cosine of our theta, what's our angle that we're working with? Well, it's 18. So we can place our 18 in for our angle. What is our adjacent over our hypotenuse? Well, our adjacent is x. Our hypotenuse is 27. So up here, this is where we get our cosine of 18 equals x over 27. So what do we put in now? Well, our next step is to set up the problems, and we get a fraction. Well, we can make our cosine into a fraction. We just put it over 1, and we can cross multiply. Or, once we set this up, we can go in and solve using our calculator. So we know that if cosine of 18 over 1 equals x over 27, well, how do we get this x by itself? This is just a regular problem, guys. We want this x by itself. So if x is divided by 27, how do we undo that? We multiply by 27 on both sides. This side we're dividing by 1, so how do we get rid of that? We multiply by 1 on both sides. So we end up with 27 times the cosine of 18 equals 1 times x. Well, 1 times x is x. We know that. So what do we do with this 27 times the cosine of 18? We come to our calculator. Our calculator, we can use the functions here to solve. So our problem was 27 times the cosine of 18. And right here, we don't have to hit enter or anything. It gives us 25.67. And if we look over here at our notes, we've rounded it to 25.68. So that's where that number comes from. So on here, guys, if we're using our tangent, we have a tangent button. If we're using sine, we have a sine button. These are the 3 buttons that we need to worry about right now: sine, cosine, and tangent. All right, so let's look at our next example. It says one problem taking up 3 sides. Yeah, that does seem to be a lot, but it's not really. Let's look at what this looks like, and we don't have to walk out every step by step. So we're still going to follow our steps. So we have our triangle. Our first thing that we need to do is label our sides. So our 73 is our angle that we're working with. So what is across from that? That's going to be our opposite. What's across from our right angle is our hypotenuse, and then our adjacent is going to be the side that is left. So we figure that out. We go to our Sohcahtoa to figure out what function that we're going to use. Well, on here we have we have a measure for our adjacent, we have a variable for our opposite, and we don't have anything for our hypotenuse, so we just mark him out. So we have our adjacent and our opposite. So what do we use? Well, if we look at here and we have our adjacent and our opposite, we know we use tangent because this is telling us that tangent equals opposite over adjacent. All right, well, we know that now. Let's go back and let's fill in our information. We have, here's our tangent. We have our opposite over adjacent. Let's fill in our numbers. Well, our angle that we're working with, our theta, is 73. Our opposite is x, and our adjacent is 12. So the tangent of 73 equals x over 12. Well, just like we did before, we can put tangent over 1 to make it a fraction, just like x over 12, and we're going to cross multiply and solve from here. So here we get tangent times 12 equals 1 times x. And we get that because we have our tangent times 12 and our 1 and x, and we solve. Well, 1 times x is x, and 12 times tangent, well, we don't know that, so we go and put that in our calculator. So here, we'll put the tangent of, what was our angle? 73 times 12. Let's see, 73. We're going to close our 73 times 12. We get 39.250. And here we have 39.25. All the hard work, the calculator's doing it for us. One more, let's look at it. We're given this green triangle here. It's a right triangle. It gives us the measure of this side, and our x is over here. We need to label. We have our angle that we're working with is 17. Let's see. Let's go ahead and label our sides. Well, straight across from the right angle is the hypotenuse. Straight across from the angle that we're working with is the opposite, and then our adjacent is just there because it's a process of elimination, third piece, third side. So now we need to look at what we have available. What information? Well, our adjacent is 20, our hypotenuse is x, our opposite is nothing, so we're marking him out. We don't need him. We need to determine which of our functions we can use if we have our adjacent and our hypotenuse. Well, if we have our adjacent and our hypotenuse, we just look through. Is it sine? No, because we don't have our opposite. Is it cosine? We have our adjacent and our hypotenuse. So yes, it's going to be cosine because that deals with our adjacent and our hypotenuse right here. Cosine equals adjacent over hypotenuse. Well, if that's what it is, let's set that up. We have set up here our cosine formula. Then we fill in the pieces that we have. Cosine of our angle is 17. Our angle is 17. And then it's adjacent over hypotenuse. So adjacent is 20 over hypotenuse, which is x. So cosine of 17 equals 20 over x. Well, we just cross multiply. Cosine of 17 times x, 20 times 1. We put in x times the cosine of 17 equals 1 times 20. Well, we don't even have to put this into the calculator, guys, because x times cosine equals 20. Okay, well, but wait a minute. The x isn't by itself like it was in the previous problems. So don't worry about it. Just undo it like normal. If you are multiplying, if we want to get this little x by itself, if we're multiplying, how do we undo each side? Well, we divide. We want to keep this x over here by itself, so we divide each side by the cosine of 17. So that's where you go and you put in your calculator. 20 divided by the cosine of 17. And it comes up to 20.91. 20.91. So what you're going to do is you're going to go in and you're going to solve for 1 and 2. You're going to decide number 1. What is all these sides? You need to label your hypotenuse, your adjacent, and your opposite. Then you need to decide which of those sides are you working with. Once you decide if it's a hypotenuse and adjacent or the opposite and a hypotenuse, you need to use your Sohcahtoa to figure out which function that we're going to use. So which function is going to be useful given the information that we have. Our angle on number 1 here is 49, and our angle that we're going to be working with on this one is 58. So remember, our hypotenuse is always across from our right angle. Our opposite is always across from our angle that we're working with. And our adjacent is always what's left. So across from this is here. This is going to be our opposite. And this is going to be our adjacent. So what do we have to work with here? Well, on this angle, we have our adjacent and our hypotenuse. We do not have our opposite. Here we have our hypotenuse and we have our adjacent, and we don't have our opposite. So what uses adjacent and hypotenuse? Adjacent and hypotenuse. Well, if we look at Sohcahtoa, cosine uses adjacent and hypotenuse. So we're going to use cosine for both of these. So now that we have that, we can go in, excuse me, and set it up. So this one we can get cosine of 49, because that's our angle, equals our adjacent over hypotenuse, so our A over H. So our adjacent is 24 over X. Remember, we're going to cross multiply here. So we're going to get 24 cosine of 49 equals X. And we put this 24 times the cosine of 49. The cosine of, what was it? 49. And that gives us 15.745. Our 5 tells our 4 to round up, so 15.75. So in this little gray box, we have 15.75. Oh. Now, over here, we still have our adjacent and our hypotenuse, so we will use cosine as well. So the cosine of what's our angle? 58. Equals our adjacent over hypotenuse. So our adjacent is x over 20. So now what do? We put this over 1 and we cross multiply. 1 times x and 20 times the cosine. 20 times the cosine of 58 equals x times 1. X times 1 is x. So 20 times the cosine of 58. We come back here. We do 20 times the cosine of 58. And we get 10.598, which the 8 tells the 9 to round up. So this comes to 10.60. Okay, guys, I know this can be super confusing, and there's quite a few steps to it. Please get this slide 17 completed. Write this out on your paper. You're going to have to use some paper with this, and you're going to have to use the calculator. So don't be afraid of either one. If you have any questions on these two, please let me know. Tomorrow we will be completing an activity where we're going to be practicing this. So don't fear if you haven't figured it out. And if you have any questions about it, let me know, guys. All right, I want you to have a great day.